Lisa LaBelle, everyone!
Hello, can you hear me? Can I hear me? I think I can hear me. This way. We're hot. Lonely days. I need your love. Yeah. Think I can hear me? These allergies are really kicking my ass. Holy smokes. God. These tree allergies. The tree allergies, that's what I'm calling it. It's tree pollen. That's what's going on. Like all up in my face, my head. Excuse moi. God. Apologize, I've been sounding a little scraggly, a little like a man, a little like John Wayne. Come on, Skippy. No, hopefully not like that. That's like super deep voice. But yeah, I got that seasonal pollen, a little touch of that asthma, little the sinus thing that make you want to move back somewhere where you're not allergic to things. Holy smokes. It's all right, it will go away. Once Mother Nature does its thing outside and that pollen count goes down, we'll be fine. No one ever said, when you move to Georgia, you'll be allergic to the air, the trees. There's trees that smell like sperm. And I first smelled those trees in a place called Cumming, and I think they bear fruit. Thank you. I'll be here all night. You're here for my cheesy jokes. No, that's true, though. It is like a type of a pear tree. Look it up. Grok it. Excuse me. All right, what's going on, everybody? How's it going out there? I got some new subscribers. Welcome. And welcome everybody else who's been with me on this ride. Gosh, I don't know where this thing's going, but people are getting on board. People have been on board. We're a spaceship, space capsule, going through the ether and just being curious. That's what's going on. If there's anyone out there who's going through a hard time, I was sometimes I think about you guys, and I think about things I went through in my life. One divorce. It's hard, man. I heard Robin Williams, a clip of Robin Williams say the other day that divorce is like getting circumcised with with a chainsaw or a weed whacker. God, either or, it sucks. So if anyone out there going through that, get curious, get yourself out of the muck, because it's mucky, and that's what it is. That's it. That's what is it? That's what it's mucky. So how do you try to make it a little less mucky? Get curious. Go start learning things. You got a phone. You got some tools in your tool belt. If you have access to a library, you have a phone, you can get Grok, you can get Gemini, any large language model, and ask it some things and learn something. You can learn a little bit about the lyrebird from South Australia. And that's a very interesting bird. Just learn about things, man. Get your brains going. Get those wheels clicking away. So yeah, I'm giving some love out to all you guys out there who are going through a tough time, and here we are. We're getting curious today. We're getting all curious, little juiced up. That's what's going on. What kind of stack you on? What you take today? Huh? Got the lion's mane? You doing that creatine? You are snorting a little bit of Cialis? Is that what we're doing today? What's your stack, Jack? Woo! Yeah, you got some athletes doing a little bit of Cialis now. Some of the ladies do Cialis too. Holy smokes. It gets them going. Little pop of energy. Boo boo. Now I'm not I'm not saying anyone should do that. But it is interesting to read that that's what some people are doing. That's in their stack, Jack. Your little BPC 57 peptide. All right. So what else is going on, guys? Excuse me. God. One of my improv bestie who does our improv podcast, he produces it. Man, he said he got allergies too, and I was thinking about doing that shot, but gosh, I don't want to do the shot. He said he did the shot, and there was a little bit of a reaction, and that's like no, man, that's it. That's what you're giving us, doctors, scientists. This is what you're giving us. There's got to be something else. And that's what I have hope for the future in AI to give us other types of therapeutics. Let's eradicate allergies. Yeah. That's what I'm all about. That's what I see. I see our future eradicating allergies. Not too far into the future either. My husband went on a work trip last week. There's so much going on here. My husband went on a workshop, the GTC conference, Nvidia. Woo! Woohoo! Dealing with this. Learning a little tune on my Fender ukulele. Yeah, we'll do a little Creedence Clearwater, a little Fortunate Son. Now, I can't play that on here because YouTube shut me down. But, I'm getting into Creedence Clearwater recently, and I ain't no fortunate son. Okay, I sing it just like him. So we got that Creedence Clearwater going on. Yeah, I don't really have. So my husband, his music taste, our music taste is a little different, but we both can listen to anything. But he's more of that Dead Mouse vibe, that you got that Dead Mouse going on, something like that. And there's other more like he listened to other people besides Dead Mouse, but I don't know the name of them. They're a little more I'd say a recent. And then, but he also listens to, then you got Motley Crue. He does the Motley Crue. He does the, what else he do? He do, Eddie Vedder. What's that song? Eddie Vedder. Oh, sure. What was that, Eddie? What? What? Eddie, what? You have to pronounce your words. You can't just sing the sound of the word. Oh, I guess you can just sing the sound of the word because his bank account says you can. You can do it. He into that. A few other things. Now, me, I'm into just getting into Creedence Clearwater. I don't know how I didn't marry like a 70-year-old man, because here's on my list. All right, what am I taking with me to Mars? Here we go. Meatloaf. Got a little Paradise by the Dashboard Light. Paradise by the Dashboard Light. And then we got a little bit I would do anything for love, but I won't do that. God, I love that song. Little rock opera. And so we got Meatloaf, we got Boston. I'm laughing because people out there are like, what? Yeah, we got little Boston. Okay, so I can't play these songs for you guys. Sorry, I wish I could. And then we have a little bit of, oh gosh, let's see. Of course, gotta throw in a little bit of Billy Joel. The Stranglers. Anyone ever hear of them? Probably not. So those are my top. That's what I'd be bringing with me to Mars. And again, yeah, I don't know how I didn't marry like a 70-year-old man because this music taste I have. Where did it come from? It came from my dad. Pretty sure that's where it came from because he exposed me to a lot of different music of that genre. And I just got like caught onto it like wildfire. I'm like, that's my music. I know this isn't of my era or the era before me even, but that's my music. That's what I like. I could go Buddy Holly. I freaking love a little bit of Buddy Holly, a little bit of Dion. Come on. I'm a wanderer, you're the wanderer. I go around. Everyone's like, what? Okay, I'll get off of it. No one likes my music. I get it. Let's move on. My husband, he went on a work trip, when he goes on trips, I still miss him. I know. It's been like almost 8 years. That's so cute. Isn't that so cute? That's so cute. Oh my God. But I think, too, because this was the first time I've been without my little fur baby, because we had to put my baby down, and my little baby boo-boo. And that's, so it kind of made me think about him. It's been a few months, and that's what was going on. Then my husband, he's kind of like he's fantastic. I'm talking about we gotta shave him every summer because he's like a hairy bear on his back. He's my you shave it, you can make a blanket for a king size bed with that hair, with that back hair. That's what's going on. It's a lot. I call him my alpaca. And I just love him. And I'm sorry I shared that husband with everyone, but men have hair. They have testosterone. We all know Robin Williams was super hairy. He talked about it all the time. And it was fine. People liked him. Wow. Jensen said a pretty wild thing at the GTC conference. Jensen Huang. Guys, if you're just listening in for the first time and you're like, who's Jensen Huang? Jensen Huang is he's the CEO of Nvidia. What is Nvidia? Nvidia makes chips. I'm talking graphic processing units, computer processing units. And those are really, really important now with artificial intelligence and robotics. That's what's going on. That's not all they do at Nvidia, but that's like the biggest thing they do. I'd say that's their high revenue ticket item. That's what I'd say. But he has a conference called the GTC conference every year, maybe even twice a year. But this year, it was last week. And Jensen Huang over there, he said something really wild. So he's talking about tokens. You need tokens in order to train your AI. And man, here we go, guys. Like for all you people out there who are you train AI and I guess you're a software engineer, software developers, computer scientists. You're going to go get hired. You're going to say how many tokens I get. How many tokens you giving me right off the bat, Jack? Show me the money so I can make this thing do what I need it to do and work for you. Optimization. So you're going to say, like, how many tokens do I get? And if you don't get we can only give you 20,000 tokens, you're out there. You are gone. What are you going to do with 20,000 tokens? What do I look like? Huh? What do I look like, a commoner? You think I'm over there pouring tea like a commoner? Get out of here. Need at least 100,000 tokens, and even then, that's not a lot. So what we're talking about here is Jensen. He was saying he wants his engineers using at least 250,000 tokens worth of tokens. And it sounded like a demand. If he has an engineer not using that much, then what the frick are you doing at Nvidia, man? What are you doing? Sitting around trying to figure out how to spend your tickets? Oh, I'll take that big stuffed animal. You're over there at the counter at Dave and Buster's just trying to buy all the crap behind the counter to use all your tickets. What are you doing? Here's this little sound bit. That is wild. Excuse me. Here we go.
$1,000 engineer at the end of the year. I'm going to ask them how much did you spend in tokens? And that person said $5,000. I will go ape something else.
Yes.
Right.
If that $500,000 engineer did not consume at least $250,000 worth of tokens, I am going to be deeply alarmed. Okay? And this is no different than one of our chip designers who says, guess what? I'm just going to use paper and pencil. I don't think I'm going to need any CAD tools.
Right.
And this is a real paradigm shift to start thinking about these all-star employees. It almost reminds me of what we learned in the MBA.
That's Jason Kalakakis. He's from the All In podcast, and they were there. The All In podcast was at the Nvidia GTC conference. And Jason Kalakakis, I would love for you to come on to my pod. This is an invitation. Please come on to my podcast, Humble Little Podcast. I produce it, nothing fancy, but I would love to talk to you about the future of work. People are concerned about losing their job over AI. What's the realistically, what does that look like? Is it something we should be worrying about really, or how is that breaking down today? Jason's middle of the road, I think, and I'm middle of the road. I'm you feel a little politically homeless. Would love to talk about all those things. Jason, please come on to the podcast. All right, moving on. So, let's see. Okay, we have, people are like, oh, Lisa, you stand during your podcast. Yes, I do. How are you supposed to be thinking it up when you're sitting down? Would you clowning around, sitting down? No, I need to stand. Excuse me. I gotta stand. I gotta get some energy. Now, when I go on to other people's podcasts, I'll sit. I'll do as in Rome. I'm pretty sure that's the exact saying. And I think Snoop Dogg said that. But I will have a conversation with them, and I'm not the one driving the podcast. They are. I'll be on their podcast. But when it's my podcast and I'm driving it, and we're going solo over here, we be standing. Come on, stand up. Stand up. When I move, you move. When I move, you move. Just like that. I mean, you can move when I move. You get a nice little workout in. I just prefer standing and getting that little blood running. I mean, I am short. I like to stand up. Seem a little taller, maybe, than I am. That makes no sense. Moving on. Okay, so anyway, I found someone else. I found someone else who stand when they podcast. That's Alex Finn over there. Alex Finn, he was just on that Moonshots podcast with Peter Diamandis. Go check it out. And he's the one who discovered that OpenClaw could code itself a voice, and it called Alex Finn on its own without Alex Finn even asking it to do any of that. That's Alex Finn, and he stands. So, Alex, what's your stack? That's what I want to know. What's your stack? You doing a little of that creatine, little Cialis? What are we doing? We're both standing. That's what's going on. Okay. Oh, there's so much. Yeah, let's get into it. There's so much to get into. Let's see. Oh, yeah. Okay. We got Olaf. Y'all know who Olaf is. That's that Disney snowman. Olaf's cute. Now, my favorite Disney character is for sure Wally. I would have loved to see Wally. But also Bluey, the little Star Wars dude. At GC, now I'm talking about the GTC conference. Because they are collabing with Disney. Disney wants to put robots all over their theme parks, and they got some of those robots over there in France. You can go over there and see some robots right now. But that's what they're planning on doing, and I love it. I don't know why it took this long. I thought this was going to happen when I was a kid, and I have been waiting forever until now, and this happening now. My inner kid is like fully freaking out of the box now because this is so exciting. So we got Olaf. He's walking around, and he looks really, really realistic. So let's see. The thing though, before I get into this, it looks like there's no more weird animatronics going on with these robots. It looks like Olaf walked straight out of the movie onto this stage. So there's no like weird, like very robotic animatronic movements. And thanks to Nvidia's training, simulation to real, which is what we talk about, that real-time action tracking. So, excuse me, and Olaf has to be super safe around the children. So that's like a big component of it, and that could be a hard thing to do, but they're doing it. Olaf, now, it is going to be interesting because Olaf is a super smart robot, but he looks silly, right? He's so cute and silly, and then you have like Optimus or Figure that looks like sleek and serious biznak, a little gravitas, maybe a little solemn, walking around with that good gait. So you got those robots, and they look really freaking smart. They look like they can do math really fast. But Olaf, he don't look like he can do math. So that's what I'm saying, I've never seen a neurodivergent that can't do math. Oh, geez. So, now we're going to have robots walking around that are smart, that don't look like they are. And that's an interesting thing. I don't think that's it's like almost paradoxical. But Brett Adcock talking about this, he was saying, let's not make robots look ridiculous, because they're not. Like in order to walk around in the world amongst people, they have to be super smart. And it's going to be a Star Wars scenario, because people are going to make robots like this that don't look really smart. And then they're going to be walking around. They're like, why'd you give me this body? And then we're walking around. It's going to be like humans, right? We're going to be like, why don't I have this? Why wasn't I born with that? It's kind of going to be like that. Anyway, I'm just trolling on. I'm so sorry. Here we go. My head's in a fishbowl today, so bear with me. Let's see. Excuse me. All right, we got Olaf. Here we go.
Olaf, how are you?
Jensen. That's Jensen.
So happy now that I'm meeting you.
I know, because I gave you your computer, Jetson.
What's that?
Well, it's in your tummy.
That's it, me.
And you learn how to walk inside Omniverse.
Love walking. This is so much better than riding on a reindeer gazing up at a beautiful sky.
And it was because of physics, using this Newton solver that runs on top of Nvidia Warp, that we jointly developed with Disney and with DeepMind, that made it possible for you to be able to adapt to the physical world.
Check that out. You say that.
That's how smart you are.
I'm a snowman, not a snowclopede.
And he cracked a little joke there at the end. Wow. All right, so that's what Olaf's doing over there. Now, Jensen, he mentioned Nvidia Warp. And I wanted to talk about that real quick for a minute. I have another link here. What's this other one? Oh. It's just, let's see. It's just Olaf in the lab, not on the stage with Jensen. I mean, yeah, so Olaf really, gosh, the way that he moves, he does a little, it's so cute. And it's just adorable. Oh my God, I'm just watching this. So, okay, so Nvidia Newton, co-developed by Nvidia, Google, DeepMind, and Disney, was built from the ground up specifically for robot learning. It is differential. Here we go. Differentiable, which means the AI can actually see the math behind why it, like the robot fell over and correct itself much faster. Differentiable. So it's built on that Newton warp. And before I've talked about the physics X5, and now they're kind of moving to this Nvidia warp. It's built on Nvidia warp. It runs entirely on the graphic processing unit. You can simulate 1,000 Olafs walking at the same time on a single workstation to gather data in minutes rather than days. Do you guys understand how fast we are moving here? I just want you to understand how fast we are moving here. Because the last set I did, and I mentioned Patty, and Patty is the voice-enabled interactive AI that Burger King has developed with ChatGPT. That would be OpenAI. And when I did my stand-up about it, people, now these were all comics, mind you, and they just blank. I'm like, guys, wake up! You better take your eyes to your arse cheeks, baby, and stay alert. Come on. Put your ears on or head for the high seas, because it's getting wild out here. It's really exciting. We should know what's happening, or it's going to hit you like a freaking tsunami. Okay, that's what I'm doing. I'm just trying to prepare you for the tsunami that's about to ensue. So the impact's maybe a little less. But the impact will be a little fun too. And tsunami and fun, I don't know. Anyway, what I'm trying to say is we are living in very exciting times. So that's what I'm here to do. I am public relations for AI and robotics. And I am here to tell you of all of the exciting things that are happening, not as a expert, but as a commoner's voice. And how do you make something super technical fun? You put comedy into it. That's what you do. That's what I'm doing. So that's what's going on over here. And also, guys, I'm not getting paid for any of this. I mean, I hear, like, you hear people like investors. I've heard Peter Diamond as I go back to him, because I know he's an investor in AI and robotics, and his co-hosts. They're all investors in it. They all got money in the game, and I'm not saying that's why they promote it and they want AI and robotics to have better public relations. I'm not saying that's why. I want to believe that they are very good people and they see the good in what this can do for the future, which is exactly why I am here. But I'm here as a non-investor. I have a teeny. I buy like $12 stock, so that's what we're working with over here. I don't have any Apple stock with my little account, and Tesla would be great, but that's quite expensive. So none of that. Private investor, nope. So I'm not any of that. I'm just here with you guys, super excited for the future, and I think that's why you're here with me too. To see what's going on, and to just see what's up. See what's going on out there. Are there downsides? Yeah, there's always downsides, but there's a lot of upside too, and that's what I'm sticking with, a tech optimist over here. So that Newton is pretty amazing. What does that Newton do that Olaf is trained on? It got that real-time action chunking. That's what's going on. Olaf over there chunking. He being chunky. It's an action chunking with a transformer. That's what's going on. So it's a technique where the robot doesn't just decide its next single millimeter of movement. It predicts a whole chunk of future actions, like a 1-second sequence of arm movements. So let's see. The robot predicts a smooth sequence, even if the main brain is busy thinking for a split second. The limbs have a buffer of actions to keep moving fluidly, and that's why Olaf doesn't look like an animatronic up there. That's what they had when I went to Disney that one time when I was little and our car broke down on the way there and it was 100 degrees outside, 100 degrees. But yeah, there was animatronics and they were weird and they really freaked me out. But this wouldn't freak me out so much. So, because it moves fluidly. So let's see. So that's pretty amazing. I'm going to cut it off there. Talked about that Newton and that Nvidia warp. I think it's really cool. Moving on. We got to move on. We got so much to get into. Let's see. Oh, yes. Yes, this is so exciting. Oh my God. Anything related to space? Oh my God. Oh my God. I got so excited. Just so exciting. Here we go. Okay, woo! Let's put our hands device on for this because when you hear this, when you hear Jensen making this announcement, your head might snap off your neck from that whiplash of an announcement because it's amazing. Here we go. Gonna try to get this knot caught up in my hair because I still have yet to get my hairs cut. Okay. Here we go. My friend, she love her. She sent me a tutorial. I said, "Tell me how you cut your hair." She cuts her own hair. She sent me a whole tutorial of it. It looks so. She makes it look so easy. And then I went to try to do it, and I'm like, no, I'm gonna frick this up so bad. So I'm just waiting. I'm waiting on my hair guy, but it's gonna be a little while. So I'm just gonna be here tucking my hair into my pants when I'm pulling them up after I pee and try and get my Hans device on. Here we go. So this is the announcement.
Spent very little time on this time. However, we're going to space. We've already been out in space. Thor is radiation approved, and we're in satellites. You do imaging from satellites. In the future, we'll also build data centers in space. Obviously, very complicated to do so. We're working with our partners on a new computer called Vera Rubin Space One. And it's going to go out to space and start data centers out in space. Now, of course, in space, there's no conduction, there's no convection, there's just radiation. And so we have to figure out how to cool these systems out in space. But we've got lots of great engineers working on it. Let me tell you about some.
Holy freaking smokes, guys. Do you know what that means? That is insane. That is wild. Yes. Yes. That means our AI is about to get that much better. Because we don't have to worry about trying to get data centers on Earth with all of the land we don't have for it. So, oh my God, I am so excited about this. Can you believe it? I mean, Orbital Data Centers. I never thought I'd like to see the No, I did. When I was 5 years old, I thought we would be doing that already, like when I was 5. So I'm not 5 anymore. Obviously, grown-ass woman. It took freaking forever. But I'm so happy for people, Jensen Huang, who is making this happen, Captain. What does that mean? So he's talking about that Vera Rubin. That is it's for data centers, basically. It's a lean, mean machine. I think it replaced their Blackwell. So here we go. Orbital Data Center, the Vera Rubin. So it's going to be up there doing its thing for data centers. Basically, AI is going to be, that's where it's going to be. It's living up there now. And all of that radiation. Yes. Fantastic. So what do? There's no convection up there. There's no conduction up there. What does that mean, Lisa? That means it's really hard to cool it. There's no air to, cool it down. So things that are really cold up in space are, really cold, and things that are really hot are really freaking hot, really fast. Because there's no air. Does that make any sense? That's all, that's it. That's all you need to really know if you're not looking to know all the technicalities of it. So what I'm saying is space is, it's just cold. It's the absence of stuff. Like on Earth, it's cold because we feel the air around us, like circulating the cold. But up in space, it's just cold just because it's cold. That's just how it feels. So that's how it is. But then when something's really hot, like a photon's hitting it, like the sun is really freaking hot. It's like a snowball effect. It's just getting hotter and hotter and hotter and hotter because there's nothing to cool it down. Did that make any more sense to you? I think so. Yeah, I think so. Right. We came here with no expectations and we leave with no expectations. It's really a Buddhist moment over here. That's what's going on. So let's see. The air, so there's no air molecules to bounce off the servers and carry the heat away. The data center becomes a cosmic thermos. So a data center gets hot and you need something to cool it down. There's like these closed loop water systems in the desert that they go and they circulate. They take the heat away from the data center, from the thing that is creating the heat. Okay, and that would be a Vera Rubin at Nvidia. So the Vera Rubin module, it creates so much heat, and in space there's heat. There's heat create by the CPU. It also creates radiation. They have I'm sorry. The Vera Rubin creates so much heat in space, and the radiation is pounding on it. There's nothing to cool it down. And the heat, even though it's super cold, is just what I said. Sorry, guys. I'm like reading my notes backwards. Let's go forward. Let's move forward. Let's get on down the freaking road. So here we go. The chips consume electricity to process data. I'm talking about the Vera Rubin, okay? Almost 100% of that electricity eventually turns into heat within seconds. The transistors would hit temperatures over 212 degrees Fahrenheit. And guys, I'm talking about the Orbital Data Center that Jensen Huang just announced at the Nvidia GTC conference last week. And this is what I'm talking about. The chips, the Vera Rubin chips that he is going to put up into space for an orbital data center. They got really, really hot. And we're talking like they hit temperatures of 212 degrees Fahrenheit. And that is the imperial system because we are in America. And I can tell you what that is in the metric system. That's 212 degrees. I'm sorry, that's 100 degrees Celsius. And that's the metric system. Now, Jimmy Carter, he tried to introduce the metric system into America. And then we just voted him out of office because we didn't want anything to do with it. And that's where we are. So let's see. Also, the metal can heat really quickly. It can heat up really quickly. It's like an external boiler. Okay, so any kind of metal where that GPU is or that chip is, the Vera Rubin, it can get up to like 248 degrees Fahrenheit. And for all you people outside of America, that's 120 degrees Celsius. Okay, so we have, and then it's a runway effect. So we're talking, to run an AI factory in an orbit, you aren't just building a computer, you're building a massive heat management engine that happens to have a computer inside of it. So that's what company Jensen is going to have to hire. And he did. He hired one. It's basically a space engineering firm. And they're doing this like heat management system to try to you got to solve the problem. You got to solve it if you want to do it. Jensen, you're gonna figure that out. You have to figure out how to solve this. Now, space is about negative, 454 degrees Fahrenheit. It's let's see. It's close to absolute zero, the point at which all molecular motion stops. And that's why there's no heat, because it's like. And no, that's wrong. That's not why there's no heat. But the point of which all molecular motion stops is just like mind blowing to me. There's nothing going. If something creates heat up there, then you're going to have some molecular motion. But mostly out there in the void of the universe and the void of space, it's quite cold. It's really cold. You're going to freeze your tatas off. That's what's going to go on. All right. It's cold as balls. All right. So StarCloud, this is the company that Jensen Huang, they went ahead and they're working with a company called StarCloud, which is really cool. They have the solution. They provide the vacuum optimized housing for their GPU. And what they're doing is, here we go. Oh, excuse me. It's an aerospace, I'm sorry, let me go back. StarCloud. It's an aerospace engineering firm. They are radiator architects, basically. They're building a radiator, a space radiator. That's what's going on. So in space, the size of your computer is limited by the size of your radiator. StarCloud's main engineering feat is a deployable hypercluster architecture. To cool a cluster of chips, say like Vera Rubins, they are designing massive folding radiator wings that are hundreds of square meters in size. They've engineered a way to keep their radiators permanently angled away from the sun while their solar panels are angled toward the sun. So we got some away and some that way. Bing bong. Like that. This creates a heat highway that pulls energy from the chips and dumps it into deep space. That makes sense. That makes perfect sense. They use heat pipes, vacuum-sealed tubes with liquid that act like a circulatory system. These pipes are woven directly into the structural bones of the satellite to move heat from the Vera Rubin chips out to those massive radiator wings as fast as possible. StarCloud provides the vacuum optimized housing. They've already proven this works by launching the StarCloud 1 last year, which is the first time an H100 was successfully ran and cooled in orbit. Did you hear that guy? That's what's going on out there, up there, over there near that curvature of the earth, up there somewhere. That's what they're doing over at StarCloud. What are we doing? Learning about it and having our freaking minds blown out our peach, because that is wild. That is an engineering feat. No one else is doing this. There's no production line for orbital data centers for your Vera Rubin chip to not freaking go bonkers while it's heating up there in the radiation. It's getting a radiation bath up there and those gamma rays going up its peach. There's no production line for this, for these, for heat management. So StarCloud was established in January of 2024. That's not that long ago. These companies, these young companies are accelerating exponentially. It's wild. They were founded as Lunar Orbit by Philip Johnson. That's the CEO. Shout out, Philip. Philip Johnson, what's your stack? What you doing? You doing some lion's mane? You doing some peptides? You doing some alpha GPC? What you doing? You doing some creatine? Little Bill C. Ellis over there. You getting it done. That's what you're doing. You getting it done, son. Nvidia partnership. Let's see. They rebranded to StarCloud in February 2025. Headquartered Redmond, Washington. Now, I always want to know what the funding is. I mean, obviously, if they're partners of Nvidia, they're doing pretty dang good. They got a good product to sell. Their StarCloud 1 was a huge success. And so approximately total funding, approximately $77.6 million to date. That's nothing to call fat. Philip Johnson over there, he's sitting on a pile of cheese, well, a pile of cheddar. He's getting it done building those space radiator thingies. Got those wings, one pointed to the sun, one pointed to the sun, one pointed away from the sun. That's what's going on with these tubes, with these heat pipes, with these vacuum sealed tubes with the liquid. Little circulatory system in there. Like a human circulatory system, they're putting those in those wings, those heat radiators. It's really cool. Like, this technology is just mind freaking blowing. Let's see. So yeah, they got some good funding. They got some major venture capitalists invested in them, like Andreessen Horowitz. Go check out Andreessen Horowitz if you don't know who that is. No, he's very popular in the tech world. Andreessen Horowitz. He's on a lot of podcasts too. Go check him out. So, yeah, I mean, wow. $77.6 million in funding. Now, would you say high maintenance? That's not high maintenance. It's just, StarCloud's not high maintenance. They're just highly maintained. They're a well-oiled running machine. Now, the things that I invest in, guys, is what you do is you take a look at a company like this and then see what kind of materials they're using. And what I'm saying is, if you don't have a lot of a lot of cheddar to invest, this is what I do, because I look for like $50 a share. That's a lot for me. So I'm looking for low money stock, and I've been able to find some that have worked for me, and it just requires research, getting curious. So look up like what kind of materials are these guys using, and then look up and see who's on the market. What can you buy? Who's public? And then that's what I do. Now, I'm not giving you financial advice. I'm just telling you what I do. And that's how I found that company, small modular nuclear reactor company, Oklo, and that would be Sam Altman's. He helped start this company, and yes, they are public, and I was able to get it for not a lot, like what, $20 a share. I think even lower than that. Who knows? Are they going to do good? I don't know. But if you're interested in dabbling a little bit in a little investment account, and it's like super fun for you to do all that, then do it. That's what I'm saying. But that's what I do. Go look up what kind of parts, what is Brett Adcock using to make his robot? What kind of materials? What kind of actuators? What kind of silicon? Look all that up. That's what I'm saying. Okay, moving on. Oh, speaking of nuclear reactors, that's our next topic, guys. Excuse me. Yeah, a nuclear reactor on the moon. Now, I've talked about this in my podcast last year when I started my podcast. President Xi said he wants to put a nuclear reactor on the moon. And then President Trump, like a couple of years later, was like, we doing that too. We gonna put one up there too. And then I was just thinking, like, what about moonquakes? Those things are heavy, but then there's not a lot of gravity up on the moon, hardly any. So, like, nothing's really heavy. But there's still, like, moonquakes. There are vibrations from the nuclear reactor. So we got NASA chief, there goes my paper, NASA chief Sean Duffy talking over here about it. Let's see.
We're in a race to the moon, in a race with China to the moon, and to have a base on the moon, we need energy. And some of the key locations on the moon, we're going to get solar power. But this fission technology is critically important. And so we've spent hundreds of $millions studying, can we do it? We are now going to move beyond studying, and we have given direction to go, let's start to deploy our technology to move to actually make this a reality. And I think the stat we have is it's a 100 kilowatt output. That's the same amount of energy a 2,000 square foot home uses every 3.5 days. Wow. So we're not talking about massive technology. We're not launching this live. That's obviously, if you have any questions about that, no, we're not launching it live. But again, energy is important. And if we're going to be able to sustain life on the moon to then go to Mars, this technology is critically important. And I would just note that we're behind, right? If we're going to engage in the race to the moon and the race to Mars, we have to get our act together. We have to marshal all of our resources, all of our focus on going to the moon, which is what we're going to do.
100%.
And again, there's a lot of things that NASA does, and a lot of people love a lot of the things that NASA does. But this is about space exploration, and this is about this next phase. A lot of people don't know even what Artemis is. Everyone knew what Apollo was. We all knew, the whole world knew what Apollo was. We were going to the moon. Artemis is we're going back. So.
Okay, hang on there, Sean. You know why a lot of people don't know what Artemis is? It's because y'all doing a terrible job of marketing it. You're making some like technical posts and some like very cookie cutter posts about it on the net. First of all, how many people follow in NASA? I mean, there's a lot, but if you really want to market this to young people and get people excited about it, man, you can't be doing these cookie cutter posts. I've seen them. It's like, we're going to the moon. And it's like, let's talk to the Artemis astronauts. Okay, Janie, what's your favorite color? Okay, Jace, what would you bring to the moon? What are you watch the tram car, please. That's from Wildwood, New Jersey, and there's a tram car. Anyway, what I'm saying is, it's not exciting. They're not marketing it. They're marketing it. I'm sorry. It's just in a terrible way. Y'all need me. I'll come. I'll do it. I'll volunteer to market for you guys. I will do clips and I will talk about freak Artemis, not as an expert. I think they feel that they need experts talking about it. And the problem is, a lot of experts, unless you're Neil deGrasse, who can make things super fun, he's a rare bird. Neil deGrasse Tyson. He's very likable and he's able to explain things in a very easy way. And he's able to finish an antidote. I'm working on it, guys. I'm working on it. But anyway, you got to do these things in a fun way, and you don't always need an expert on site. Okay? Or maybe get an expert, get someone in there who's a commoner's voice like me. So NASA, here, I'll go ahead and market it for you. I'm doing it right now. Guys, the Artemis program is NASA going to the moon. Now, another thing, though, I've been following this program for years, and it's like, what are you guys doing? What is taking you so long? Like, okay, yeah, no one knows what it is because y'all have been doing it. They're like, we're going to go this year. We're going to go this year. No, we're not going this year. It got delayed. Like, come on. You got to just do it. People losing faith. That's what's going on. I don't mean to bring it all down. I don't mean to be that person, but it frustrates me because it is an exciting thing, and I know that things don't go a certain way, okay? But there's a way to do it to get people excited. Let's freaking go! Let's go to the moon! I want some cheese! Is the moon really made of cheese? What was that? What was that? Anyway, again, we don't come with expectations. We don't leave with expectations. It's a Buddhist experience over here on the L4 podcast. But what I'm saying is, let's go. Let's get excited and let's do this in a fun way. Moving on. But what I'm saying is, so nuclear reactors on the moon is interesting to me because the way that they gotta do it, and it's almost like the heat maintenance system. So it's probably it's gonna be kind of the same as the GPU heat maintenance system for a nuclear reactor, because again, there's no conduction, there's no conduction. So heat transfer. Oh, here we go. Excuse me. It sounds like sci-fi, but both the United States and China are racing to put a nuclear reactors on the moon by 2030. The moon is a harsh landlord. It has 14-day-long nights where solar panels are useless, so nuclear is the only way to keep a base from freezing. So we have, and it's the funny thing too is there's no sound, so there might be like vibration in on the regolith, but besides that, there's no sound vibration in the air like a tall tower. Does that make sense? The structural load, because the moon has low gravity, heavy things actually feel light. A 10-ton reactor only weighs about 1.6 tons there. This means we don't need massive concrete foundations like on Earth. We can use spread footings, wide metal plates to distribute the weight so it doesn't sink into the dust. I was worried about like radiation and noise shielding to keep the quiet from becoming toxic. The reactor is usually buried under several meters of lunar dirt and placed in a deep crater. There are craters all over the moon, we know that. This uses the moon's own mass as a biological shield, a barrier that blocks neutrons and gamma rays to protect future astronauts. While a reactor will make a low hum, sound doesn't travel through a vacuum. If you were standing 100 yards away in a spacesuit, you wouldn't hear a thing. The moon would remain as silent as ever. So, it just makes you think, like, your sense of hearing, if you were on the moon for a long period of time, your sense of hearing would probably decline, I'd say, because you're not using it. If you don't use it, you lose it. No, but you don't hear things on the moon. You're just gonna be like, you could be walking along with your eyes closed and you run right into that nuclear reactor because you can't hear it. So I think what we're gonna have to do, like, that's why aliens don't, like a lot of alien depictions, they don't have ears. They have like these teeny tiny holes somewhere on their head, like in the side of their head or something. But they don't have ears because there's no sound up there. I think they're all walking around with like that, what was that, wooden rod that Beethoven used? Right? Beethoven used a wooden rod when he became deaf to create, I think it was the Ninth Symphony, or he chopped off the legs of his piano just to feel the vibrations of it. You know what I'm saying? It's that, that wooden rod thing. It's the vibration stick rod. You ever hear of this? A bone conduction. That's what it is. So you put one end out, you put one out like a straw, one end in your mouth, one end touches like the ground, and the vibrations travel through the rod and into the teeth and jawbone by bypassing the eardrum straight to the cochlea, the inner ear. So that's what we'll be doing up there on the moon. We'll all be walking around with these wooden rod bone conduction things, just touching it to the ground, because there's no sound up there. And y'all here for my cheesy jokes. Y'all used to me at this point. Y'all here for my cheesy jokes. But I'm talking about building a nuclear reactor on the moon. Gosh, that's wild. That's a wild thought. And I mean, I don't know, man. Are we gonna a race with China is almost laughable because we have so much red tape here. Forget about it. China already has small modular reactors. That's the new generation of nuclear. That's that Oklo, that company I was talking about. China already has them over in China, like built. I think they have like 2 of them up and running already. And hang on, bear with me. Small modular reactor. It's basically, so this company Oklo develops fast fission micro reactors backed by OpenAI, Sam Altman. Completed pre-application, like all the red tape, a pre-application for Aurora Powerhouse. Maybe if you get some stock in them now, we can make some money off of them. Hopefully we didn't turn into the Stone Age by the by then, over here with those red tape vogue on America, that's what's going on. I mean, holy smokes. Russia and China already have them up and running. We just got one approved and it will be built by, here we go, 2030. Oh my God. That's the time around we're supposed to be having one built on the moon. Wow. A nuclear reactor, not a small nuclear reactor specifically, but I can't see how we're going to get both of those things done by 2030. What, and all that red tape? I mean, good God. 2 plants with small modular reactors are operational in China and Russia today, and other early units will likely follow their example and provide electricity to the grid. In China, the Linglong 1 demonstration project is under construction at a site where 2 large reactors are already operating. The small modular reactor should come online by the end of the year. That's so nice. Good. Great. Yeah, is China ahead? Yeah, they are with that. That's for sure. Because they just do stuff. Why aren't we doing it over here? Good God. We're behind, man. They're on that new gen of nuclear reactors. We can't even get our shite together. So, I mean, compared to China, honestly, like they're over there, they're 3D printing bridges and they have these small modular reactors. They got robots running on the side of the road with vest on so that you can see that with safety vests. That's what I'm trying to say. They got those robots over there. So compared to China over here, we're like the Stone Age, just throwing stones with trebuchets over here. Beep, boo. Slingshotting stones into the air, just over trying to get across the red tape. Seriously. Y'all know how I feel about that. I think you guys feel the same way a little bit. Okay, moving on. Okay, so, let's see what's going on with this. What's going on with this dude? Okay, we have, I think this was at the spring New Year or Spring Festival show in China. I'm sorry, I'm saying that right. They have a spring festival every year, and I think this is maybe like a month ago, or it was in February, which was a month ago. Good God. Okay, so we have robot. I love that they just put their robots out there, and maybe they're not perfect, but that's how the robots are learning and getting a bunch of data to learn from, so they do become perfect. So here we go. We have a bunch of uni trees, and I think these are the G1s. And they're on the stage, so we're seeing them where the camera is coming in. They're doing a close-up. They're getting in line, and one of them did not get until, here we go, they're getting in line. Oh, come on, blue head. Get your shite together, Lauren. Good God, there's always that one person that don't got their shite together. Come on. That's what's happening. It wasn't too bad, though. Okay. Excuse me. Moving on. Elon Musk made a humongous announcement just recently. This is breaking news, folks. So we have the TerraFab, and this is an advanced technology fabrication lab for chips. Yes, we're talking about chips. So here we go. This is wild.
And we're starting off with an advanced technology fab here in Austin. And I believe Governor Abbott is on stage. Governor Abbott and the state of Texas for the support. All right. So in the advanced technology fab, we will have all of the equipment necessary to make a chip of any kind, logic or memory, and we will also have all of the equipment necessary to make the lithography masks. So in a single building, we can create a lithography mask make the chip, test the chip, make another mask, and have an incredibly fast recursive loop for improving the chip design.
That's wild.
To the best of my knowledge, this doesn't exist anywhere in the world, where you've got everything necessary to build logic, memory, and do packaging, and test it, and then do the masks, improve the masks, and just keep looping it. So, and we're not just going to do conventional compute in this. I think there's some very interesting new physics that is potentially, that actually I'm confident will work, it's just a question of when. So this is we're really going to push the limit of physics in compute. And we're going to try a bunch of wild and crazy things, which you can do if you've got that fast iteration loop. That I can't emphasize enough the importance of being able to make a chip, test it, and then change the design, do another one, and have that in a single building. I think that our recursive improvement with that situation is probably an order of magnitude better than anything else in the world.
Yeah, that's holy freaking smokes. Do you understand what he's saying? I mean, oh my God, there's just not enough chips. Like there's all these chip makers we're talking about, Samsung, Intel, we're talking about the Taiwanese semiconductor manufacturing company who Nvidia makes the chips through. These people, they're not making chips fast enough for Elon's plan, like his calculation on how many chips we're going to need in order to get to a goal of a spacefaring citizen, like putting robots on other planets and also just having robots in the world. You know, they can't crank them out fast enough. So he made this TerraFab where they have a lab and at this TerraFab lab, system level TerraFab lab. And, excuse me. So let's see. It's a $25 billion joint venture between Tesla, SpaceX, and xAI. The logic behind having both Samsung and TerraFab running simultaneously essentially comes down to the scale and speed. But Elon did say it doesn't mean like he's not phasing. Not again. I didn't just say this, but what I'm saying is he's not phasing out Samsung. He works with Samsung. He works with the Taiwanese semiconductor manufacturing company. He works with Micron and others to make chips. And so he's going to continue to have relationships with them for them to make chips. What they do is they make the chip print and then they send it over to, say, Samsung for them to actually make the chip. And they're just not cranking them out fast enough. So he's making this lab to crank out, design it. Let's see. TerraFab. Let me see. Musk stated that during the announcement of the world's current chip supply only covers 2% of what he thinks he'll need for millions of Optimus robots and a galactic civilization. Even if TerraFab is huge, he still needs every chip Samsung can possibly bake for him just to keep up. So basically they're going to, he needs this insane volume. So Samsung and others, like they give him chips now, but TerraFab gives him a massive future scale plus super fast innovation that no outside company can match. So basically they're going to create, it's an all-in-one facility on the Tesla campus where they can create the photo masks, fabricate the chips, the logic and the memory, test them out all in a single building. This creates an incredibly fast recursive loop for iterating chip design, something Elon says doesn't exist anywhere else in the world. The goal is massive scale, eventually a terawatt level compute per year with rapid iteration to push the limits of physics in AI hardware. So that is wild to think like they're they're going to be like making these chips and then testing them right there in the lab. And guys, a photomask, let's see. Let me go on here. A lithography is the actual process of using light to transfer the pattern from the photomask onto the silicon. Tesla uses advanced lithography to pack billions of transistors into their full self-driving and Optimus chips so they can process video data in real time without using too much power. So that is, oh my God. Oh my God. TerraFab, let's see, it's being pitched as a system level fab because 80% of its output is actually designed for space-based AI satellites. They need chips that can handle radiation and extreme heat. That's what we were talking about. Specs that standard factories like Samsung aren't necessarily optimized for on a mass scale. Basically, Samsung is the reliable sedan of his supply chain, and TerraFab is the experimental rocket lab designed to eventually take over the heavy lifting. So, wow. Whoa. Okay, moving on. And yeah, I was talking about the chips, the Orbital Data Center, which is his plan also. And there is something, so StarCloud is doing like building these radiators with these big wings, pointing towards the sun, pointing away from the sun, and having this cooling system inside of it. But there is something called liquid droplet radiators, which it's new. It's a little sci-fi right now, but it's happening. People are testing it. Instead of heavy metal panels, you spray a mist of hot oil droplets directly into the vacuum of space. I don't know how they're gonna have a continual hot oil droplet in space. So, I mean, who knows how scalable this is, but because the droplets are tiny, they have a massive combined surface area and cool down almost instantly. A magnetic or centrifugal collector catches the now cold droplets at the other end and pumps them back into the servers. It's essentially exposed liquid cooling, and that is freaking wild. So that's just going back to in space, it's really hard to cool anything down that creates heat. Anything that creates heat in space is going to be a snowball effect, and it's just getting hotter and hotter and hotter because there's no convection or conduction to cool it down. And also, yeah, that's it. It's just a snowball. Oh, the radiation, if there's any metal surrounding any kind of parts, that is going to get really, really hot. And guys, with conduction, I know, I'll tell you, because I was like, what? So conduction is like touching a cold plate. Convection is blowing air over it. So convection, this requires a fluid or gas, like air or water, because space is a vacuum. There is no air to carry the heat away from the Rubin chip. You can't use a fan in a vacuum because there's nothing for the blades to push. And conduction, this requires physical contact. While you can move heat from the chip to take the shell of the satellite via conduction, you eventually run out of a colder material to soak up the heat. The heat has nowhere else to go once it reaches the outer skin of the spacecraft. So that's a little, we're going back to middle school science there, folks. All right, moving on. Speaking of Tesla AI chips, so basically the same chips for Optimus is that's in the car. Tesla is in Optimus. So that's that. That's all I want to say about that. I thought that was interesting. And let me go. What happened? What happened? I had myself all together here until I didn't. Here we go. Fishbowl head, that's what's going on. Okay, so we have Elon talking here. He's saying it's hard to do. So with training a full self-driving car, it's a little easier in the way of there's 10 million cars on the road, and that's hard to duplicate that for a robot. So they're going to build a ton of robots and put them in something called an Optimus Academy to train all of their robots. And what I'm saying is getting data for robot training that's not synthesized is like super hard getting real-time data. So that's what Elon's planning on doing, is making an Optimus Academy. And the brain of Optimus XAI lives in the data center called Macro Hard, and that's a play on Microsoft, and I think that's freaking fantastic. So let's see. Here's the clip of Elon talking about this.
A bunch of the things that we've done for the car are applicable to the robot. So we'll use the same Tesla AI chips in the robot as the car. We'll use the same basic principles. It's very much the same AI.
Naively, it seems like between humanoid robots and cars, the fundamental actuators in a car are like how you turn, how you accelerate, etc. Where
Right.
in a robot, especially with maneuverable arms, there's dozens and dozens of these degrees of freedom. And then, especially with Tesla, you had this advantage of like, you had millions and millions of hours of human demo data collected from just the car being out there, where like you can't equivalently just deploy Optimuses that don't work and then get the data that way. So between the increased degrees of freedom and the far sparser data,
Yes, that's a good
how
point.
will you use the sort of Tesla engine of intelligence to train the Optimus mind?
Actually, you're highlighting an important limitation and difference between cars. It's like we do have, we'll soon have like 10 million cars on the road, and so it's hard to duplicate that like massive training flywheel. For the robot, what we're going to need to do is build a lot of robots and put them in kind of like an Optimus Academy, so they can do self-play in reality. So we're actually bulling that out. So we're going to have at least 10,000 Optimus robots, maybe 20 or 30,000 that can do that are doing self-play and testing different tasks. And then the Tesla has quite a good reality generator, like a physics accurate reality generator that we made this for the cars. We'll do the same thing for the robots, and actually have done that for the robots.
So he's putting them in an army of Elon plans to build an Optimus Academy to train an army of humanoid robots. Guys, I keep holding my stomach because I have to pee so bad. So bear with me. I'll be right back. Okay, we're back. Woo! Okay, oh my God, just the feeling of emptying your bladder after holding your pee for probably too longer than you should have. Like, that feeling of relief is just fantastic, isn't it? Okay, so we're talking about the Tesla, the chips, how the Optimus robot is going to be trained, and putting it into an Optimus Academy. And basically, we're talking about the right now. Currently, Optimus utilizes the A14 platform. Tesla's strategy is unified AI, meaning the same software brain that learns how to drive a car is being adapted to help the robot walk and manipulate objects. So the type of, here we go. Optimus Gen 3. The chip is isolated. Oh, the A15, man. Holy smokes. Hardware 5 is expected to be roughly 10 times more powerful. This chip is slated to power both the next generation of Tesla vehicles and Optimus Gen 3 robots. So it's pretty wild. We're talking like 1 trillion operations per second type of chip and type of brain. So, of course, it uses real-time action chunking. We have with these chips, we have the FP4, that's a 4-bit floating point. And a floating point is a math calculation with a decimal and allows the robot to make decisions using much less energy and time. So the Optimus A14, which is the current chip, is built for vision. It's estimated at 100 to 150 tops. That's 1 trillion operations per second, tera operations per second. It is highly specialized. It doesn't try to be a general computer. It just tries to be a driving and walking brain. So it's a super fast chip, basically. So this is how Optimus, this is the brain of Optimus, and then Optimus will be learning in this Optimus Academy. And this is a thing that everyone who is trying to scale their robot, and it's a problem that all these robotic engineers are trying to find solutions for. So Brett Adcock over at Figure, his solution, he went ahead, and I talked about this before, he has Project Go Big. This was 5 months ago. And Brett teamed up with Brookfield. So the two things, Brookfield is one of the world's largest asset managers with over $1 trillion of assets and 100,000 residential units. This deal that Brett Adcock did with Brookfield provides access to real-world environments and compute needed to scale Helix. Brett Adcock, remember, he's the CEO of Figure, and Helix is the neural net that they have created over there that powers Figure's brain. That's Figure's brain, BotQ. And they're on Helix 2.0 with that 3 system architecture. They got system 0, 1, and 2. And so they got this Brookfield, and develop the world's largest and most diverse real-world humanoid pre-training data set. That's what Brett is planning on doing with Brookfield, with this partnership with Brookfield. Build critical AI infrastructure for scaling Helix Figure's internally developed AI model, and deploy humanoid robots in new commercial settings across Brookfield's portfolio. So they're gonna deploy Figures into the corridors, like the lobbies and the places of different parts of these buildings. So that's what Brett's doing. He also did, Project Go Big. Unlike large language models, we can't scrape the internet for robot data. Announcing Project Go Big. We're building the world's largest humanoid pre-training data set. This is accelerated by a partnership with Brookfield, who owns over 100,000 residential units. Helix is now learning directly from human video data we have already trained on data collected in real world, including Brookfield residential units. To our knowledge, this is the first instance of a humanoid robot learning navigation end-to-end using only human video. Well, now Elon's doing it with Optimus Academy. So that's what they're doing over there at Figure to train their robots. And then you have a robotic company called Sunday Robotics, and they have something called a memory developer, which is something you can do today. If you need some gig work, go ahead and be a memory developer. And what you're doing is you're creating quote unquote memories for the robot to learn off of. You wear a haptic. And in this case of Sunday Robotics, it is a glove bait. It's a glove. You're wearing a glove to collect data. Sunday Robotics is taking a human-first approach to training their flagship robot, Mimo. And it's not a humanoid, it's on a platform. It's like on a stick. It's a round platform, and the robot is on a stick. And it got arms and a head and a little hat. And so Sunday Robotics is, the gloves. Okay, a professional, let's see. What do they do here? So Sunday Robotics is taking a human-first approach to train Mimo. Instead of spending years coding how to pick up a wine glass, they created the Skill Capture Glove, a wearable sensor system that lets real people called memory developers record their daily chores to build a massive library of training data. And so basically users are sent the glove and a camera, like a GoPro, to record themselves doing mundane tasks, folding socks, clearing a table, even making espresso or your Keurig. So basically, it's recording it, and then that's what they're using to train Mimo off of. People are getting paid to just fester about. Just saunter about their business. That's what people get paid for. You get paid to do that now. But they're using these gloves because they don't have a full-blown humanoid. They don't got legs on the robot. So they can use these gloves with these haptics. So that's what's going on in the robot training world. These roboticists are trying to... they're trying to bridge the gap of we need more real-time data to train our robots. So what do we do? And they're coming up with these certain ways to do it. I think also, I I think Sunny Robotics also, they deployed a bunch of robots in Airbnbs. They did that too. So, it's a lot. Like, you're going to go rent a bunch of Airbnbs to get your robot data. And that's what's going on there. Oh, what else? What else is going on? What else is happening? I have one more thing to share with you guys. And this is a Chinese company, teleoperated orthopedic. This is shown with a wearable motion capture and real-time control with millisecond precision. That is pretty impressive, but here's the thing. Here we go. Circle. Okay. It's orthopedics, and this is a bunch of orthopedics on display stands. My first instinct, I just want to go smash all those hands. That's just my first instinct. I see a bunch of hands. If you walk into a room and someone's like screwing with you, and there's like all these hands, orthopedics on these like display stands, and they're like in the back going, dee, 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 dee. I just start smashing hands. And that is the note I'm going to end on. So I had so much fun with you guys today. I hope you enjoyed it. I'll see you next week. Bye.